So this week we're going to move in and start looking at chemical reactions. And so to start off, let's look at chemical and physical properties. So when we have some molecules, as you can see over here on the right, and you already know that these have both physical and chemical properties. But what are those physical and chemical properties? Well, physical properties, these are the things that we've probably been looking at for the past while in class. These are properties that you can make of a material simply by looking at it, by measuring it through direct observation. And as you're looking at these materials, like you can see on the screen here, you could say, oh, well, that material is green in color. That would be an example of a physical properties. And as you're observing these things, the chemical nature of the material does not change. These, like I said, could be just direct observations or measurements, like we could measure the temperature or the mass or the volume. Those are examples of physical properties. Some physical properties are what we would call intensive properties. And that means that they do not change with the amount of matter in the substance. So if I had, for example, gold, if I had one tiny speck of gold, its density would be the same as if I had a whole truckload of gold. So again, those are intensive properties. They don't change with the amount of matter we have, like the color, the temperature, the specific heat, whether it can be made into a wire or not, its ductility, its viscosity, its ability to flow or resist flowing. Those are examples of physical properties that are called intensive. The opposite of that is an extensive property. These are properties that do change with the amount of matter we have. So these would be things like the mass or the volume, things that we're going to measure in the lab in chemistry. Again, more physical properties. A physical change is a change in the matter that doesn't actually change the identity of the matter or its chemical structure. So if you look at the diagram there on the right, we've got a physical change going on here. We've got liquid water. You can see the water molecules, the two black hydrogens and the one red oxygen, H2O, and it's becoming water that is a gas. Again, we have not changed the chemical nature of the molecules. So they're the same molecules, we're just changing them into a slightly different form. So this is an example of a physical change, a liquid becoming a gas. We could write that right here at the bottom of your screen on the left. You see liquid water becoming water that is a gas or gaseous water. Now, chemical properties, these are the kinds of things that we're going to observe during a chemical reaction. And this is when one chemical substance turns into another chemical substance. In other words, what happens in a chemical reaction? Chemical properties cannot be examined without reacting the sample in some way. So we're going to change the sample as we find these chemical properties. And here's some examples of chemical properties. Toxicity, how poisonous is something. Its ability to damage our living cells. Flammability, heat of combustion, how much energy is released when the substance burns. Obviously, if the substance burns, we won't have the substance anymore. So its chemical nature will have changed. And that's what occurs in a chemical change, when one substance turns into a different substance. This is also known as a chemical reaction. So if you look here at the diagram on the right, we have liquid water. Again, you can see those water molecules. And for that liquid water, we've got a battery here, and the battery is taking this tub of water and separating it into the two substances that make up liquid water, hydrogen gas and oxygen gas. And so you can see the gas forming in these test tubes. Right here, you can see, obviously, there's more hydrogen gas forming than oxygen gas, and that's because there's more hydrogen in the liquid water molecules. And that's going to be very important as we start to represent these chemical changes with chemical equations, like the equation you see right above there. And so as we're writing these chemical reactions, and that's what we're going to be moving to do, we're going to write those as reactants with an arrow, and on the other side are the products. The arrow can be said as yields or forms. So in other words, reactants form products, or reactants yield or even produce products. So here's an example of a little chemical reaction. This is a copper wire that was placed in some silver nitrate. So just a solid copper wire, and this is a liquid silver nitrate. You'll be able to see it moving around during this quick chemical reaction. So take a look. The wire was already in there for a second before I was able to start the video. So on the outside of the wire, you're now seeing silver forming. And so we could say that the copper wire reacts with the silver nitrate. That would be a chemical property, and this is a chemical change or a chemical reaction. And so how do we represent a chemical reaction? We represent a chemical reaction with an equation. And as we're writing our equations, we have a few shorthand ways to note what the chemicals were. Like, for example, we would put S for solid. So in the example we just looked at, the copper wire was a solid, so we could represent that copper with a Cu for the copper, and then next to it in parentheses we could put that it was a solid, because that's the format that our copper wire was in. If we have a liquid, we could represent it with an L, and that's usually done with a cursive L. Aqueous for an aqueous solution. And in the last example that we just saw, I mentioned that that silver nitrate, which of course silver is Ag, nitrate of course is NO3. And so you do have to write the equation or the formulas correctly to be able to write the correct equation, and that was aqueous. So that was just dissolved in water. You'll remember that most solutions use water for the solvent, and so they form aqueous solutions. Or we could put G for a gas. And so it's important to be aware that during chemical reactions we often use these abbreviations so that somebody could repeat our reaction exactly the way that we did it and use the solid copper wire, for example. All right, so in that chemical reaction, again, we had copper and silver nitrate. So we just simply read that equation like that. Copper and silver nitrate, or copper reacts with silver nitrate to form, to yield, or to produce silver and copper nitrate, is what was going on there. Now, we don't want to write it out just like that. So what we'd want to do is use a shorthand way to do that. With solid copper, obviously, reacting with aqueous silver nitrate to form solid silver, that's that silvery stuff that was forming on our copper wire, and copper nitrate. And of course, as I mentioned earlier, we do have to write these equations correctly. You'll remember that, or those formulas correctly. You'll remember that this is copper 2 nitrate. Nitrate is a -1, and I probably should have put that 2 right here, that it's copper 2 nitrate. And when we cross those over, we are going to get copper 2 or copper nitrate with a 2 on the end there. And so that is important. And so as we're taking a look at this, one of the things that you'll notice is that the number and type of reactants and products is a little different, that we have 2 nitrates here and only 1 here. And so that's going to be important because we do have to be able to balance these chemical reactions, that the number and type of atoms on the reactant side, the left side of the equation, have to equal the number and type of atoms on the right side of the equation. And so we would have to balance this equation. The way that we would balance that equation is we'd have to kind of look to see how many of each item we have here. And as we're doing that, we would look and say, okay, so how many coppers do we have on the left? 1. How many coppers do we have on the right side? 1. How many silvers do we have on the left? Right here, just 1. And silvers on the right, we have just 1. Now, if we look at nitrate, the great thing about nitrate in this equation is that the nitrate stays together. We have 1 nitrate over there on the left, and we have 2 nitrates over here on the right. So to make that equation balanced, we would have to add a big number in front here. Now, that big number in front there is called a coefficient. It's just like if you're in math class and you wrote something, and we use it just like if you're in math class and you wrote something like this. 2x plus y is obviously going to equal 2x plus 2y. And so that big 2, that coefficient, goes to everything that is behind it. And so that's important for you to be aware of. That's the way that happens. And so now we have 2 silvers over here on the reactants side. So we're going to need 2 silvers over here on the product side. So we're going to have to add a coefficient 2 in front here. And now we can just sort of double check to make sure that we are balanced. And that's usually what I like to do, is sort of just double check to make sure that I'm balanced. So I have 1 copper, 1 copper. Copper's balanced. I have 2 silvers, 2 silvers. Silver's balanced. I have 2 nitrates, because again, that 2 gets distributed to everything behind it. So I have 2 nitrates. Yep, 2 nitrates. And on the product side, 2 nitrates. So my nitrates are balanced as well. And so once again, you add those coefficients to balance the chemical equations. And once again, this should have been copper 2 nitrate, so that you would know that that copper was a plus 2. And so that's how we use chemical equations to represent chemical changes.